Go ahead.
All right. Well, good evening, everyone. Thanks for coming to Chic and Code It. And we're also partnering with the Jacksonville Artificial Intelligence Meetup. So thank you all for joining us. Tonight, we have a very special guest, and so we're excited to have her. So without further ado, well, let me see how we met her. Well, Swati was recommended to us by Jan, or introduced us by Jan, one of our members, active members of Chic and Code It. And I spoke to her, and she definitely has a heart for not just about technology, but encouraging women or anyone, especially in the data science space. And we thought about making this about career development night and talk about, how do we get a lot of the members or young ladies out there who wants to go into this space, and so talk more about that. So anyway, so Swati, welcome, and maybe you could tell more about yourself, and then we'll go from there. Okay.
Thank you so much, Sarah, Jan, all the meetup groups in Florida. Like I said on LinkedIn, anybody now, since it's online, anyone in the world can join this meetup. So Jan, thanks for introducing me to this group. Jan and myself go a long way. I used to work in Philadelphia at a company called SunGuard along with Jan from 2008. I worked there from 2008 to 2013. So we were very good friends, but a little bit about myself. I've been a technologist for over 2 decades and held a lot of positions in the world of technology. I was a developer, I was a product manager, I was a director. And since moving to the Washington, D.C. area, I was senior director at Amtrak, managing their whole applications development, like Amtrak.com, mobile apps, the whole team. And a few years back, I got into the world of machine learning and data science since I was very interested to learn. So I did a lot of self-learning. I started implementing projects. And currently, I'm a chief technology officer at a healthcare services company here in Washington, D.C. We provide all sorts of solutions, predominantly for CMS and HHS. Since we are in D.C., the federal government is our bread and butter. So currently I'm working on a number of exciting AI ML projects. One of them is using machine learning in lung cancer to detect the adipose tissue of CT scans of lung cancer patients who have undergone surgery and find the correlation between adipose tissue of lung cancer patients and how they would recover after lung cancer surgery. And then most recently, we prototyped using machine learning to predict the risk factor for veterans' suicide. That's with the Veterans Administration here in DC. So a number of multiple machine learning AI projects have been leading here. So it's an exciting world, and I'm aware of multiple hats. I last year got inducted into Forbes Technology Council, where I blog about AI and ML on Forbes.com. I'm also a Women in AI ambassador. Women in AI is a nonprofit that started in Paris, but it has members from over 100 countries now. And I'm the Washington, D.C. ambassador. And our goal is to increase diversity in artificial intelligence. So this meetup is perfect to achieve that goal, to spread the news and awareness. So that's a little bit about myself, but I want to know a little bit about you all. If you come off mute and want to say, I want to see a show of hands or in the chat window, or if you want to come off mute, what sort of roles are you currently engaged in? What sort of job? Just so I can tweak a little bit of my talk towards that. Anyone in the chat want to come off mute?
If you want, I can start.
Go ahead, Sarah.
Okay, so I'm a director of product architecture in Legality, and we do have several projects in AI and machine learning. We have a big one coming out, or doing a few kind of a prototype this mid-June. So I'm really interested in learning about that. I haven't really done any AI stuff. I have been a developer like you and kind of moved on to, management leadership roles. But it's something that I think it's good to get into and get to understand. And I hope the ladies here I've heard a lot of young ladies are developing, wants to get into this space and want to know how to start there. So that's what I'm interested in learning today, is helping this ladies with that kind of shift. Or I guess it's a little bit of a pivot, maybe. I don't know. Maybe something we could talk about.
Absolutely. Anyone else want to share? I'll see whether we have any. You can also type in the chat, please. I just want to understand how many are from technical background or non-technical background. So anything that you can share would be helpful. Go ahead, Jerry.
Hi, thank you. Welcome, everyone. I know Vivian through the artificial intelligence or the augmented intelligence, and I am my company is Leverage Unlimited, and I work in the area of producing Zoom hybrid events.
Interesting. Thank you for sharing. And I see a few in the chat, software developers.
Hey, Swathi. I'm Rhoda Mean. I'm an enterprise data architect at Sudeth International, which is a global moving company headquartered here in Jacksonville. I actually joined Sudeth, I want to say last year. I have over 20 years experience in data and artificial intelligence and machine learning. But Sudeth wants to get into AI and machine learning. And as you know, it's not a cheap project to get into. There's costs involved. So I guess from your viewpoint, what's the best way to, I guess, convince senior leadership that AI and ML projects are worth it, when we enter this budgeting phase of IT, which is what's happening now at Sudeth right now. So that's one. And number two, to this group, I have a position that's part-time that I've been trying to fill for the last, I want to say 3 or 4 months. Someone junior, someone who wants to get into data science and, data solutions. So that's just, if someone's interested, please reach out to me. Trying to fill that. It's hard to fill it with good people. So.
Thank you. And the question you asked, let's hold off your question. If you can bring it back after my session, because I know you asked a loaded and very important question, but I also want to cover initially how to pivot into a career of data science and then address that question, if you don't mind holding it off to the end of the towards the end of the question session. Somebody is from high school. Awesome. I love it. I recently had a hackathon for middle school and high school kids to celebrate International Women's Month in March. And it was very interesting to see amazing creative ideas. It was called Girls in AI, and it was in collaboration with an international organization called Teens in AI from the UK. And just today I heard that 900 kids participated from throughout the world, and the team that participated in the hackathon here won the design award. But we had our own awards, and then they collaborated with all the countries in the world. So I'm super excited to see some high school representation here.
Me too. Welcome, Marie.
We see account managers, staffing, quality engineers, some more developers, project managers. Yeah, it's very important for everyone to understand what's the possibilities of AI, tech recruiter, Python programming. Oh, I love this.
Yeah, we have a diverse group of people here.
Yeah. Got certified on Azure. So exciting stuff. I love it. So without further ado, let me share my screen, and I have a presentation here. So the way I'm going to, the flow is today, I'm going to cover a little bit about what is AI, what is data science, and then about what is machine learning, and what is the life cycle of an AI use case, and then move into who is a data scientist? What does success look like for a data scientist? There are various jobs in the world of data science that I'm going to cover. And then I'm going to give some practical tips how to pivot and go further into data science as a career, how to assess your skills, and what are some 5 ways to go about getting into data science as a career pivot point. So let me share my screen here. Okay. Let me know when you can all see my screen.
Yes, we can.
Okay, let me put it in the presentation mode, actually.
Okay.
How's that?
Looks good.
Okay. Okay, so first let's start off with what is artificial intelligence. We know the term has gone over the hype cycle, according to Gartner, and today where we are, there is definitely more talk about data science as a career and then AI. So going back to 1955, 1956, the term was first coined by John McCarthy. He was a professor at Stanford. And he said that it's intelligence demonstrated by machines as compared to intelligence by humans. One of the things I want to emphasize is the last sentence. It's an umbrella term, and there are many subfields that range from robotics to machine learning. And you can see all the subfields over here. You have vision and speech and language processing and expert systems and robotics and machine learning. So when it comes to data science, machine learning is the crux of it. I mean, robotics is its own field of expertise that uses machine learning, but when it comes to data science, most of the projects we are talking about uses machine learning. So before showing the next slide, again, I want to make it a little interactive and ask you all, what is an AI product or application that you use every day? You can put it in the chat or come off mute and let me know. Come on, there's so many things we use that has AI in them, whether we know it or not, like it or not. So any examples or any products you think you're using? There you go, facial recognition on iPhone. That's a great example.
I use
Anything else?
AppRiver for my Outlook, and it automatically filters all the spam out, which makes my life a lot easier.
That's awesome. Yes, spam filter, predictive analytics. Yes, that we see on Amazon and we can't help ourselves but shop more. Search engines, yes. Anything else? Okay, I think you've covered a lot. Voice commands, phone apps, Google Photos, chatbots, product recommendations, speech recognition, self-driving cars. Yes, I think we have covered the gamut of everything. Yeah, a lot of examples. So here I present a few. We already said the product recommendations, Amazon, what to watch next by Netflix, and then of course, all the voice systems. The phone tagging on Facebook is another thing that uses machine learning. And then Uber uses machine learning for price surges during rush hour. And then we already said spam filters, and Waze uses it for route optimization as well. So what is machine learning here? And I know a number of you might already be working on this, but I want to tell a simple example based on my movie watching experiences on Netflix. And last night I was super excited about the Oscars since I'm a huge movie buff. But here I present a simple example of what is machine learning. Essentially, I love to watch Oscar-winning movies. Like someone likes to say, if there is an Oscar bait, I'm the one to line up first. So all the Oscar-winning movies represented by green, which I have watched on Netflix. And then there are some, most of the genre that I watch is drama. And then sci-fi and Golden Globes are lesser of the movies that I watch, represented by Red X here. And so given a new movie, which is represented by a yellow box here, what is the probability that I will watch the movie based on my past viewing experiences? So essentially, that is a machine learning algorithm where you don't explicitly write rules like in traditional programming, but you automatically learn from vast quantities of historical data. So, and we use statistical methodologies. So this is an example of machine learning. And then in the context of machine learning, we hear a lot about different areas that are like subdivision under that. There's supervised learning, which essentially means you learn from data that's already has the input and output variables. So for example, if you want the machine to recognize a cat, you feed it a lot of photographs labeled cat. That's supervised learning. And unsupervised learning is essentially you don't label them. You feed millions of photographs of cats and dogs, and the machine will try to identify patterns across and cluster the dogs together and the cats together. That's unsupervised learning. I'm oversimplifying it here just to understand the concept. And then we have reinforcement learning. Essentially, robotics uses a lot of reinforcement learning. Essentially, it's almost like a game to show the robot, okay, try to climb up this wall. It will keep trying and trying until it's successful in it. And then there are natural language processing, which is based on linguistics, which intersect with machine learning. So a lot of you said examples of chatbot, which typically uses NLP and NLU, natural language understanding, as well as voice bots. And then machine learning has further newer areas that are being used called deep learning. Typically, we use that in image processing and so on. So this is a very high level simplified overview of the world of machine learning. And so what are the key steps of implementing an AI use case? So this is important to understand how the role of data science fits in the spectrum of the job group of data science itself. So over here, we start obviously with a business problem to solve. I like to say to all business users, AI is not the pixie dust that I sprinkle and you get magic. It cannot solve world hunger, but you have to start with a business objective. And that's important to brainstorm a little bit because sometimes AI might not be the right tool. And that's important to know as well. And a huge factor in that evaluation is the ethical considerations of AI. And I've done a lot of work in that area. That's a topic for another day. But it's important to ask your business stakeholders, what are some business objectives you're trying to achieve? And one of the things that goes back to the question that Rhonda asked is how do you convince business users, right? It's a two-way conversation. When I'm talking, I recently had a conversation with the deputy CIO at Center for Medicare and Medicaid here in Washington, DC. And he was very confused. What is the possibility or what are the questions to ask for which machine learning is the right answer? So that is something that a good data scientist will educate a business stakeholder about. What are the possibilities? What problems can you solve with machine learning versus traditional software programming, since most of you have developer background. So that's crucial to understand. And once you understand that, for a typical data science or machine learning problem, it's mostly a prediction problem. Based on historical data, you would be predicting something. Even if you take the case of self-driving cars. So before Tesla put the cars on the road many years ago, it actually captured it has many components. Image recognition took a lot of photographs of all the roads in different road conditions, when it's raining, when it's snowing. And so it's a culmination of a of a lot of machine learning algorithms that are inside a self-driving car. Sensors capture the road conditions and so on and so forth. Even there, based on that historical data, the car is able to identify what sort of, whether it is a stop sign, what does that mean? So for any machine learning problem, data forms the crux and the core of starting point. So you identify your data sources, then you do some data analysis. And here it's very important to understand the business rules. And I say the heuristics of business rules because sometimes those business rules might not be written down. It might be in someone's head. And if you want the machine to learn from that, we need to understand what are the heuristics. And then once you get the data, you divide it into training data set and validation data set. This is because you want to make sure you get reproducible results. And then this is where, when we say model, you're talking about a machine learning model, and then finally you deploy it to production. And the deployment could be in terms of a web app, a mobile app, or just a Tableau dashboard. So again, in the case of the lung cancer research example, basically the data analysis was we took a lot of CT scan images, and we actually sat with a radiologist who does this work currently manually. A radiologist, he actually looks up at a CT scan image of a lung cancer patient, and he manually finds out where is the adipose tissue and calculates it. And we were trying to use deep learning and machine learning to automate that. So we actually sat with the radiologist to understand how he manually does that. And that is what I mean by the heuristics or business rules. Until you understand how they currently do something, you cannot automate it. So, and then we took, like we had about 232 CT scans. We divided them into training data set, which is about 80%, and then the test data set, which is 20%, so that once we take 80% of the 200 CT scans, we make sure that the program has a high level of accuracy before we test it on the remainder. So this is just how the machine learning works. It's an iterative process, and the important point to remember is the data analysis. So if you take your data, you want to understand, is all data useful, or there is some data that is not pertinent to the machine learning problem you're trying to solve. So sometimes some data we have to, decide not to use. The other thing we do something is called feature engineering, which is important. Basically, sometimes there would be null values for data. Sometimes there's not enough representation of the data. So we have to, as data scientists, make some decisions what to do with that data, whether to use median. So there is a whole process, how to deal with data that has null values. So the data analysis component is huge, and most of the machine learning projects I've worked on, it's almost takes up 60% of everybody's time, because sometimes as data scientists, you don't even understand, like again, to the lung cancer research example, we had to go back and have multiple conversations, both with the radiologist and the lung cancer surgeon, because they're the ones who know best what each of the data points represent. As data scientists, you have to be like lockstep with your stakeholders and domain experts to understand what the data means, because you have to make a lot of decisions. So this is the life cycle of a machine learning algorithm before you make it operational. So having said that, who is a data scientist? So put it very simply, a data scientist makes sense of data, but they also understand the business problem they're trying to solve. They typically have understanding of maths, statistics, and one of the programming language, either R or Python, both are most popular these days, and then deploy in visualization, either on Tableau or Amazon tools, or even as a web application. And then on the right, I have, they do a lot of data wrangling and feature engineering. I told you an example. And they build machine learning algorithms, and they finally put the algorithms into production, which is machine learning models. So this is like a huge, I'm covering a whole lot here. And depending on the organization, some organizations which are large can have multiple people to do multiple things. Sometimes they say, okay, we have a data engineer who might take care of all the data wrangling. And then we might have a DevOps engineer who might take care of making or deploying the machine learning models in production. But a lot of times they expect the data scientists to do almost all of these steps or some of these steps. If I have to narrow down a few steps that are mandatory, I think making sense of data, understanding the business problem, and machine learning and data wrangling are the must-haves for a data scientist. You can ask, is a data scientist someone who can make sense out of an Excel spreadsheet? Yes and no. I mean, an Excel spreadsheet is as rudimentary as it could get. There is no repeatability there. There is no programming that you can use for complex patterns. So mostly these are the mandatory features that's expected out of a data scientist. Of course, it's touted as the sexiest job of the 21st century, and average salaries are, even starting salaries, 100K and beyond. And a very good senior data scientist is going up to 200K and beyond. So I want to pause here and take some questions because I have covered a lot. I want to make sure you all are following with me before we move on to the next slides. Any questions? Let me see the chat. You can also put.
I have a question, Swati, because when I was in school, and this was way back, and I don't want to date myself, but there was really no term data scientist, or they called it something else. So I'm assuming these are not anything new, right? Is it just something that they've encapsulated into one role and one person?
I love that question. That's an amazing question. Although data analysts have been there for a long time, and also statisticians, data analysis, I feel, is statistics on steroids. So we have had traditionally for the longest time statisticians and data analysts. The data scientist has come into play as a new job. It's slightly different. And the reason is, in the last 5 years, the compute power has increased. You now have a compute on the cloud that can crunch petabytes of data in a couple of hours, right? So a couple of things that has helped data science as a new career is enhanced compute, enhanced silicon chips that enable image processing. So if you take from 1956, when the term was first coined, to almost like 10 years ago, when people started using machine learning, what they called is the winter of AI, because conceptually, everybody knew how machine learning works. Starting from 1956, there were published research papers, but we were not able to make them operational because the compute did not catch up. And compute has to catch up to an extent that is affordable to everybody, and cloud made that possible. So that's a great question. I think the reason it's more of the last 10 years, people were able to start writing machine learning algorithms. And nowadays you have, if you follow NVIDIA or Intel, they have better and better processing chips, especially for image processing. It takes vast amounts of compute, and you do need faster chips. So compute power and the cloud enabled data science as a job, and the ability to write machine learning algorithms even on the cloud very quickly, depending on your data again and the quantity of data, compared to 10 years before, where it was very theoretical. AI as a field was theoretical. We knew the possibilities, but we couldn't have enough compute. So as the compute increased, one was access also to the cloud, the cost becoming cheaper. Everybody is now able to play with data. So that is the reason that it enabled data science as a profession. I see something on the chat. NVIDIA for the win. Yes. Yes, I follow them closely because especially for image processing, we still have a long way to go, like depending on, I was only talking about 232 CT scans, but if we want to have very high accuracy results, we need to process multiple millions of images. And for this, we need really high processing chips. So any other question? In the chat, or if you want to come off mute. Okay, so let's move on to the next. Okay, so what does success look like when you are in the career of a data scientist? And this is with respect to a business. If a business wants to hire a data scientist, I'm not saying in terms of monetary benefits, that's always there, but a business looks at a data scientist as a data hacker. You should be a communicator to communicate with the stakeholders. You should be an advisor to them when to use AI or machine learning and when not to use. And we need to understand the problems they're trying to solve. At the same time, tell a story with the data, whether it is verbally through dashboards or even visually through videos and so on. The underlining factor is you need to come at it with intense curiosity to go well beyond the depth and breadth of the problem that you're trying to solve. So I'll tell you another simple example. I was advising somebody who was working on a data science problem, and they were predicting the delay of the flight, whether the flight will get delayed or not based on historical data of delays because of weather. So one of the questions I asked was, do you think the problem you're trying to solve is predict that the flight is delayed because of the weather? Or do you think the problem that you're trying to solve is to predict the flight is delayed? Very similar questions, but there's a lot of nuance in your underlying data and the problem you will try to solve, and the accurate results and the expectations of the stakeholder. So it's our job as data scientists to go back to the stakeholder and say, what are you trying to solve? Is that a weather-related problem, or is you just want to know if the flight is delayed? What are you trying to predict, right? So this is the job of the data scientist, to enable your curiosity and ask those deep questions to make the stakeholders think about what is the exact problem they're trying to solve. Because if it's just weather-related delays, then your data set will include all the weather-related delays. But if you're saying just delay of the flight for any reason, then it's a bigger universe of data. So, and sometimes stakeholders do not think, they just say, okay, we want to predict the delay of the flight, right? So we need to dig deeper and ask those questions as a data scientist. So use your curiosity and so it's not just technology skills, that's a given that you need to have those all skills of writing your algorithms, but very important is how do you tell the story with the data. And even when your outputs are predicted, usually you never get 100% accuracy out of a machine learning algorithm. So if there is 80% accuracy, the question is, can they live with 20% inaccurate or false positive results in terms of patient outcomes and health? No, 80% is still not acceptable. In terms of flight delays, maybe so. So it all depends on the problem you're trying to solve and what those iterative questions that you need to ask. I'm seeing something in the chat. Most of the success relevant skills apply to all types of careers, then interface technology and business. Absolutely, I agree. But I think in data science, it's still such a new field that a lot of stakeholders are still challenged with understanding the possibilities of it. So that's the only newer thing that's come into play. So what are the various jobs in data science, right? So you do here, obviously data scientist job postings is the most common one, but in the world of data science, you also have data architects and data engineers, machine learning engineers, decision scientists and researchers. So you find all these different job postings and sometimes depending on the organization and when you interview, that's very important to find out. You need to ask enough questions to find what is expected out of you. Sometimes they expect a data scientist to do all these jobs. They expect them to do data architecture and data engineering and build machine learning models, become a researcher and so on. But sometimes it could be that data scientists are only expected to work on a business problem, do the data analysis and machine learning, and everything else, they have other people who have those jobs. So what is a data architect? I know somebody on this in this meeting is working as a data architect. So do you want to come off mute and tell a little bit so that we all understand it? Was it Sarah? Sarah, did you say?
Oh, it was Rhoda. Rhoda, are you still
Rhoda.
on?
Hey, yeah, so I'm an enterprise data architect. So basically my role is, I guess, finding the projects and building the solutions that align with the business mission and strategy. But the data architects that report to me, they're more of the designing the solution, understanding the business problem, knowing the newest technologies that's available to us, and designing a solution that's cost effective and meets the requirements.
Can you be more specific? Did you mean, are they implementing a data warehouse and a data lake?
Sure. So that's one example. One example is we are moving to the cloud for our business intelligence platform. So one architect is designing the data lake, the structure of it, how the data files, the unstructured and structured data files are being stored in the data lake. Another data architect is doing the modeling around the enterprise data warehouse or the data marts that align to what the business needs in terms of reporting. And then I've also dealt with data architects that do basically data integration within business applications within the enterprise, right? So we have a lot of systems that talk to each other. So it's defining the data integration that happens between the systems and, so there's different levels of data architecture that we deal with. Yep. And then there are some that is around, machine learning and artificial intelligence.
Awesome. You covered the breadth. So that's typically what the data architect does. Like we said already, that machine learning models rely on vast quantities of data. So it's important for any organization who wants to implement machine learning models, set up their data warehouse. So that's another question. If you're getting into data science positions or you're interviewing, that's a question to ask to the organization. Do you have an established data warehouse? Because if the organization is like a startup and small and they don't have a data warehouse and they expect the data scientists to do, then you're chewing more than you can, you're biting more than you can chew, because typically you want the data warehouse to be already established. So for example, if you have a sales transactional system that records all the sales data, you as a data scientist will not go and take all the sales data coming from mobile, coming from web app, and you consolidate that and put them in the data warehouse and then do data analysis. No, typically as a data scientist, you expect somebody else, a data architect team, already to have done those steps, and then you go in and the data should be given to you to do your analysis and feature engineering and build the machine learning models. But depending on how large the organization is, they might or might not have a data architecture team. Typically large organizations do, but it's always good to ask the question. Data engineers. So data engineers is taking data to the next step. After the data architects actually architect the data warehouse. The data engineers would mostly validate the data sets, and they also make sure they either have batch processes or real-time streaming based on how frequently the data is changing. They also could set up the data pipeline. So for example, if you're using, somebody mentioned Microsoft Azure Cloud, there's AWS Cloud. If you want to ingest the data automatically onto the cloud, then you need to build those pipelines. So you have those roles of data engineers doing the automated data pipelines or building those data pipelines. Then they have explicit job description called machine learning engineers. That's few and far between, but sometimes you do see, I think machine learning job in machine learning engineers is the closest in terms of the job family to the data scientists, because most data scientists are machine learning engineers. And then decision scientists. So decision scientists and researchers are sometimes used interchangeably. This is people where they have PhDs and they're coming up with newer techniques of machine learning. So typically you see this in the big tech companies like Facebook and Google. They are the ones. So Google has an out-of-box tool called TensorFlow. Facebook has a huge Facebook machine learning algorithmic teams, and so on, right? And so if you hear the word decision scientist or a researcher, you are going to not solve business problems where you're using machine learning, but find newer techniques of using machine learning, whether it is a tool like TensorFlow. And there are many other tools. Google has another tool for natural language processing called Dialogflow, and so on and so forth. Then the IBM has their own proprietary tools. So these people expect to do more research, more deep math, advanced maths to come up with newer ways of machine learning. So these are the various jobs in the data science family that you hear about. So the first step I would say is, if you want to pivot into a career in data science or AI/ML, is you want to take initially a step back and do a brief assessment, an assessment of what are your current skill set, what are your current career goals, what are some priorities, and where does your passion lie, and where do you want to go. Sometimes, there are opportunities to enhance current skill sets. And then career goals, maybe you want to get into a leadership position. So is that coming in the way of you pivoting into data science? Because once you pivot, you might not get the leadership position in data science immediately, depending on which organization you're going to. And then priorities. Sometimes when we have a lot going on, making multiple changes. So for example, you're also doing your master's or MBA, or you're having a baby, or these multiple changes you have to prioritize. So make sure you do that assessment of what is your priority in terms of when you want to pivot into a career in data science. And then passion. Most of you are developers, some are program managers, even recruiters who are passionate about Python programming. If you know what you're passionate about, like you might be passionate about not necessarily machine learning models, but building data pipelines or architecting data lakes, which is also a crucial step in the spectrum and the life cycle of a machine learning algorithm. So it's important to make this assessment before you can take an active step to invest time, money, resources to actually pivot into a data science career. So here I present 5 ways to actually get into the data science as a career. So first is graduate or master's degree. So this option is for those people who do not have a graduate degree. Only that I would recommend. Even if you have a graduate degree and it is a non-technology field, it's fine. You can then go to option 2, because this is one of the most expensive options and also time consuming. So essentially, if you want to do the graduate or master programs, there are a lot of universities that have started offering data science graduate and master programs. So you search, most importantly, you want to concentrate on the curriculum and teaching professionals, because most often if the university is concentrating on just theoretical and a lot of professors don't have industry experience, then it's going to be a huge gap between what you learn and what is practically possible in the industry. So make sure when you search, you assess the curriculum. Obviously, you might have a budget in this, in whatever budget you want to play. And then you're looking at math, statistics, and computer science as part of it. The cost could typically be between 50 to 70K. This has been taken from some research paper on the cost, but it could be less or more. And then you're looking at a 2 years minimum for graduating before you go, but to real world projects. So this is an option. Again, for those of you who do not have a technical degree, you shouldn't worry. Again, I would recommend opting for the next step, next option. But this is still, if you want still that warm and fuzzy feeling that you still want to do the graduation master program. And also maybe sometimes we think that there is more credibility in the master's program, but I have spoken to a lot of data scientists who have done boot camps, which is my next option I'm going to cover. And these data scientists are working for large organizations like Etsy and Warby Parker, and not necessarily gone through a master's program. So this option, again, think carefully, make your assessment and judgment before you go for this option. The second option is bootcamp. This is the most popular option. So basically, I think with the pandemic, the good news is you have online options. Before that, most of the boot camps with the rigor was in person, but I think pandemic has opened doors for both online and in-person programs. The boot camp is advantageous because it's a short time frame and they're very focused on project-based. Most boot camps are very project-based and they're focused on getting you a job onto data science. But it's most of the rigorous and good boot camps like Metis and Galvanize are used to be in person and maybe now they're online, but they are like a full time. It's like they don't have the part time. The really good ones have a full-time boot camp where everything is project-based. There's a lot of networking opportunities. They will also introduce you to companies who are recruiting and so on. And then there have been a lot of other boot camps that have cropped up along the spectrum, but you have to be very judicious. You want to look for a boot camp that is offering not just full-time and intensive curriculum that is project-based. You also want to look for teachers who are teaching this boot camp who have actual industry experience so that you know that they are going to help you in real life scenarios-based projects. And typically the boot camp will cover statistics, machine learning methods, intermediate programming, and real-world use cases. For those of you who are already developers, I think it's a very easy switch. Most of the programming languages in machine learning are R and Python. So if you've worked on Java, C++, it's an easy switch. I think what are the new skills you will pick up is actually statistics, because most machine learning foundation is based on statistics. So again, it's 8 to 15 week intensive. These are I'm talking about Metis, Galvanize. These are the best of the best. That gives you a lot of opportunities for networking and jobs and so on. So somebody asked in the chat examples. Can you please elaborate?
I think they meant bootcamp examples. I think you mentioned Galvanize. What else?
And Metis, METIS, Metis.
Okay.
So even if you sign up for Metis newsletter, you will come to know, even before joining, sign up for their newsletters and come to know about what's going on, what type of curriculum. They send a lot of newsletters with their alumni, interviews with their alumni and so on. So that will give an idea for you to make a decision before you invest money or time. Any other questions for these two options before I go on to the next option?
Swati, the same line of questioning for a graduate program, you said watch for curriculums. Do you know of any schools or, that you'd recommend that are good at this?
Yeah, I mean, there are so many. University of Michigan is really good, and they do have, I think I'll cover it in the option for self-learning, but even if you want to do online program, University of Michigan is really, really good. I know UVA, University of Virginia, recently started their data science masters. So those are the two that comes to mind, but again, use your judgment, where you're located, whether you want to do in person. Oh, somebody mentioned, yeah, Georgia Tech, obviously you can't go wrong with Georgia Tech. So yeah, I mean, you really have to think about why you're doing a graduate and master's. And if the answer is because you think companies do not take people from other options, then you're wrong. Companies have been hiring people who have gone through boot camps, including Google researchers. I follow a lot of Google researchers on Twitter, and I'm a huge fan of self-learners because I'm a self-learner. I did my engineering in India about 20 years back. And since then I have picked up all the programming languages on my own. So if you build your portfolio, and I'm going to cover the next one as a self-learning option, but definitely think twice about why you want to go back to school. If you think because companies are biased against people who don't have the degree, that's not true any longer. So this option I'll spend the least time on. You will see that in the world of data science or machine learning, a lot of PhDs. I think there are more PhDs than others, and you will question yourself. I know, like, people who are vice presidents at Amazon and other companies have thought about doing their PhD. I have thought about doing my PhD. So anybody and everybody always has this thought. But I would say, again, in the world of, if you don't know Rachel Thomas, I highly recommend following her on Twitter. She has a blog on fast.ai, which is her company, but she's a PhD in maths, and she highly recommends not to get it. She says getting a PhD feels like a safe option, and it's a well-defined path to doing something considered prestigious. And she also says it's a narrow range of skills and they're less transferable. That's her personal experience. And she also thought that there's a lot of lost opportunity cost. So for example, she said she spent after her master's multiple years to do PhD, and her co-founder of this company called fast.ai, meanwhile, was launched 2 startups and sold the startups and got more practical skills. So essentially, what I would say is, if you think you want to introduce new type of programming language in machine learning, or new techniques of machine learning, or something like solve one particular problem using machine learning, you're very passionate of a narrow particular field, then you have to go for your PhD, and more power to you. That's all I can say in a nutshell. Someone said we need our data scientists to be expert programmers. Sorry, expert, lost that.
He's saying they're better luck hiring CS types background than PhDs.
Yeah,
to your
do
point.
a PhD if you care about the science of the science, for the science sake. Maybe look at a distance learning part-time PhD, look beyond the US. I think Andreas has some good advice there. Yeah, because it's a lot of commitment, and you really have, if you want to get behind the science of how it works. And it's interesting, there is a lady called Sarah Hooker, if you want, you all follow her blog. She works as a researcher on Google Brain, and she doesn't have a PhD. So there are a lot of examples of people who actually do research without a PhD as well. It's just, what is your commitment to self-learn, or get into practical projects. Yeah, some PhD folks do struggle because they have a lot of theoretical concepts, and not practical examples. So all good points. So the fourth option is self-learning. Self-learning, obviously, everybody has different motivation levels. You have to have really high motivation levels for self-learning. You need to have a daily schedule. You need to make sure you have some accountability partners, because that's the checkpoint for you. You can evaluate some online courses, Udemy, Udacity. I recommend Code Academy. Code Academy is more driven by short quizzes, making sure you understand the concept along the way and so on. So I love Code Academy. Of course, Udacity, Udemy, they're all there. So there are a lot of online courses, but self-learning, you do require really high motivation, and get your hands dirty on a project sooner than later. And the other thing about self-learning is you do have to network very, very actively, proactively on your own, just like you're all attending this particular meetup. There are a lot of meetups out there, or reach out to people on LinkedIn, ask for advice and so on. So a lot of boot camps give you that option of networking, as well as obviously if you're doing a graduate program, you will naturally network with people. But with self-learning, those are some of the things. Make sure you consciously set aside time to network and talk to people who are in the same boat as yourself, so that you exchange notes, solve problems together. Sometimes you're stuck and you can get demotivated. I'm guilty of it. If once I get stuck, I get demotivated, and I really have to go and ask some people. There is a Facebook group called Tech Ladies. I highly recommend you join. They have advice anywhere between data science, computer science, legal, discrimination. It's an amazing group started by a few ladies in Silicon Valley. They have thousands of members throughout the world. So if you want to find an accountability partner or compare notes, that's another place. I'll go to the chat. A lot of things have been said. Also consider, get your name out, advocate for yourself. Yes, I have covered some slides about blogging and everything. Microsoft MVP, regional director, has nothing to do with formal qualifications really, but it's quite visible if you work on the Microsoft ecosystem. Took on Cody, third-party add-on project, someone trying to data science, they know Python, it won't be hard, they can bump it with job working down. I'm hiring 5, awesome. So that's the next option, which somebody covered, it's on the job. So a lot of you are already developers, so try to explore in your organization, whether it's the sales department, whether it's the finance department, marketing, operations or product, explore what's going on, have a lot of water cooler conversations. I know with the pandemic, it's more difficult, but ask somebody for a virtual coffee conversations and see either they might already have some data scientists in their team that you can pick the brains, or it's a new problem that you can solve, and start learning only one skill at a time. Don't push yourself too much, because again, you are volunteering to contribute within your organization. I think this is the lateral move within an organization is the best way to pivot into data science compared to anything else. But again, you have to be smart, you have to be proactive, you have to be upfront with the person that this is the reason that you are volunteering and so on. So this is how a friend of mine from, a lot of people who are from the finance background actually get into data science because they're already doing number crunching. They might already doing statistical modeling. I do know, and I used to consult at a fintech startup, and they were already doing like some linear regression for and modeling, and it's very easy for them to pivot into data science. So awesome. So how to stand out? I know somebody already mentioned. I would recommend this step is almost like it will give you an edge. edge compared to others, because again, I was interviewing and recruiting some data scientists. We got hundreds of resumes. A lot of young people are opting that for to graduate and doing master's programs. So I think this is important to focus on for you to stand out. And I think if you're already a developer, you have an edge. You understand business problems. You understand how to communicate with stakeholders. You understand mission and vision of organizations. So use it to your advantage and blog about it. If you're comfortable in video, doing videos, you can talk about it. So essentially you do a project and you just blog about what the project is about. If you have solved a problem as to predict prices, housing prices in Jacksonville during the pandemic, and you did a machine learning model, just blog about where did you pick the data from? What is the data analysis you did? What is the machine learning model you did? What are the lessons learned? What is the accuracy you got? And share insights. And even if it is wrong, like sometimes initially a lot of data science problems I worked on didn't get high level of accuracy. Even today, it's like 52%, which is almost like heads or tails, but you still sharing insights, blogging about your journey is powerful. So to stand out, I would say most of us are comfortable writing, so you can do a blog and publish, and obviously give links to your GitHub repository as well. But if you're more comfortable on video, please go ahead and do that too. So I highly recommend. So nowadays, I mean, the world is your oyster for the options. You work on your projects, you blog, you also network, like meetups. Like I said, and another interesting thing is the pandemic has opened doors for meetups in like, you can attend any meetup. I started attending some Silicon Valley meetups just to know what's happening. I was invited to a lot of meetups in New York. So I feel like we should take advantage of this virtual world we are living in and network with as many people, if not more people than before. You can watch videos. A lot of good machine learning technique videos are on YouTube. So you can watch videos if you want. You can contribute to them. Obviously, you have a GitHub repo where you can put your machine learning models, listen to a podcast or start a podcast, whatever you're interested in. So there are a lot of options if you want to be proactive. I'm going to the a lot of people said they get the source code from GitHub. Which is better, getting directly into data science or becoming a developer or database before getting into the field? So if you're not a developer, the steps to get into data science, you can go with the step number 1 or step number 2. If you're not a developer and don't have technical background, graduate or master's program can give you a technical background. But again, some boot camps require a prerequisite of technical skills. So check out some boot camps that might not require, and they can cover from the basics as well. But you do not need to become a software developer before getting into the field, but you need to understand the prerequisites of data science. So 1 is maths, advanced math, calculus, and so on. 2 is statistics. Statistics is the foundation. And 3 is a programming language like R or Python that are universally used, and it's open source. So yeah, somebody said Python, but R is also used. So any other questions? I think we're almost at the end. So those are some options for you to think about. And I have a YouTube channel called the AI ML Show. I recommend you all to subscribe, and please connect with me on LinkedIn. Whatever is your social media channel of preference. I do post a lot about data science. I post a lot about ethics in AI and policy and regulation of AI. So that's another topic that's close to my heart. How do you get Spark experience without access to huge data? I don't know what you meant by Spark experience, but I will interpret it as how do you start getting experience without access to huge data?
Apache Spark, I think.
Apache Spark.
Yeah.
So actually you have a lot of publicly available data sets. So you go to Kaggle, I will put it in the chat. You have, I mean, there are so many publicly available data sets. In fact, initially we struggled to search for lung cancer CT scans, even those we found publicly available. So you think about any area, even medical healthcare, there are a lot of publicly available data sets. And there are some data sets where you can actually buy. So we worked on another problem for lung cancer research to predict the readmission rates of lung cancer surgery patients. And for that, we were actually able to buy the data sets. It costed us $1,500 per year of data from the government. Actually, they maintain the data set. So, but you don't need to spend money. You have a lot of publicly available data sets. Go to kaggle.com. That's where they have data science competitions, and they have a lot of publicly. Just search for whatever data set you want. Very insightful, learned a lot.
Yes, thank you, Swati. Very good. I learned a lot too. I was going to ask if there's anyone that would like to ask more questions besides chat. We'll give them this time to do that. Swati, if that's okay.
Sure, absolutely.
Don't be shy. Well, I think maybe you did such a good job.
Oh, I'll go back to the question that Rhoda asked initially. They said,
That's right.
How do we convince a business user to prototype on
I guess to
AI/ML
invest.
projects?
How do they invest?
Yeah, I would say you do not. Don't try to convince them. You have to talk the language of stakeholders, which is basically what business problem you're trying to solve. So if the stakeholders is vice president of sales, the best thing to go about is, are you trying to prevent customer churn? Are you trying to increase revenue? And think about problems that can help. So preventing customer churn is a very common machine learning problem, prediction problem. So put yourself in the stakeholder's shoes and think about what's in it for them. They don't care about the sexy new technology. We do as technologists. They care about business goals and business problems that they want to be solved. So if it is a VP of finance, maybe fraud detection is a great use case. So think about that, and then you start slow, right? If you can collect data and have a concept of what you're trying to predict before even you can do a hands-on. So that's one area. And I can tell you with high degree of confidence, for starting a small prototype, you don't need a bunch of millions of dollars. If you have to make it into production, yes, you need. But if you're experimenting or trying to convince them, start with small, quick wins. Like I know a large organization is trying to do a proof of concept within 6 weeks and see what are some predictions they can do. So start small and see what are some quick wins, but also think about what the business problems you can solve using machine learning.
Okay, thank you.
Other than informs, where are good places for data scientists to go like this type of engagement? I don't think I understand that question.
Other than informs, I'm not sure. But I do want to ask you, Swati, a question. Maybe
Sure.
you can expand. You mentioned ethics in AI. Can you, a brief description or overview of what that means?
Oh, absolutely. And I didn't want to cover a whole bit because I give talks especially on that topic and it's a topic, but I want to cover, yes. So one of the risks of using artificial intelligence is basically you can have negative outcomes. So I'll give you 3 examples. One, if you're using machine learning algorithms to predict if somebody can default a credit card or a loan. So essentially, if you run a small business and you apply for a business loan, the bank can reject you, or it can say yes to your business loan request. And sometimes banks have started using algorithms to determine if me, Swati Young, what is the probability that I will default if they give $1 million. So if the bank is using that algorithm and they used historical data where they did not have data about women owning businesses, guess what? The data is skewed. The data has bias. So
That's
when
a
they
good
reject,
point.
when they
Wow.
reject me, it's a biased decision, and that is a risk and a huge challenge. So essentially, since most AI and machine learning is based on historical data, there is a risk of amplifying inequalities in society. There is a risk of having biased outcomes against certain population sectors. So that is number one. Number two is the legalities. So for example, for a self-driving car, it's still not clear who is liable in terms of an accident, whether it is the developer who writes the program, whether it is the investor who invested money in the startup, whether it is the tester who's put a stamp of QA and said this is QA. So there is a lot of legalities and liabilities of some systems. And thirdly, there are artificial intelligence use cases which is detrimental to society. Facial recognition systems have been banned by the use of police and law enforcement in the city of Boston and San Francisco because it is used for surveillance purposes and invading in people's privacy. The second is deep fakes. If you have seen during the previous election, Nancy Pelosi's drunken video, that was a deep fake that is actually causing a threat to national society, national security and society at large. So there are many use cases of AI systems that have gone wrong. And interestingly, European Union just last week introduced a lot of regulations. You cannot use artificial intelligence and machine learning in recruitment, because guess what? Traditionally, historically, women are not on the same page as men for recruitment in jobs or promotions. And so a lot of cities, New York, they have been campaigning to actually regulate use of AI in recruitment. So all these use cases have a lot of implications on society, negatively detrimental to inequalities of society. So AI ethicist is a new job that has come up. Mostly philosophers and neuroscientists are taking up, but one of the jobs I do as a data scientist is that I come up with the rigor that the data scientists also can evaluate ethical AI outcomes along the spectrum, starting from data to machine learning to outcomes and business user conversations. So that's my long-winded answer.
Oh, no, it was very good. Thank you so much. Sure, we can learn a lot from that.
Absolutely. And if you subscribe to my channel, I have a lot of conversations with AI ethicists. One person that comes to mind is Angskar Kuna. He's the AI ethicist for Ernst & Young. He's a global AI ethicist for Ernst & Young. He's the head of global AI ethics. So there's that video of my interview with him, and a lot more on AI ethics I cover.
Okay. One last call. Anyone else? Calling? Going? All right. Okay, well, thank you, Swati. This was really good. I know that we recorded this, and Swati, you can use it in your ML channel, AI ML show. I would definitely check it out now. I'm going to subscribe.
Thank you
so
so
if you guys
much.
want to see it again, this was really good, Swati. We really appreciate. I learned a lot personally. So
absolutely, my pleasure. And more women, I encourage more women to come into AI. Guess what? Because like I mentioned, ethics and bias only women can eliminate. We bring that different perspective to the table. So I wish you all best of luck to pivoting your careers into data science. Thank you so much.
Thank you. Thank you, everyone. Have a good night.
See you next time.
Thank you.
All right,
Bye.
bye.
Anna, did you stop the recording? No.